Good evening, everybody. This is Mr. Lowe with today's lesson on the area of a triangle and a parallelogram. So, a couple of real brief review. Triangle obviously has three angles, which is why it's called a triangle. We have a parallelogram over here, which is basically it is two pairs of parallel sides. So when I say parallel sides, I mean that this side right there is parallel to this side right there. And this side is parallel to this side. So we have two pairs of parallel sides to make a parallelogram. As we move into today's lessons, you are going to want to take some notes. You're probably going to want to be drawing lots and lots of pictures so that we can kind of get things through. So we have two areas to calculate. We're going to focus on the area of a triangle first. We have two ways to calculate the area of a triangle. So first, let's go make a triangle. So I'm going to go over here and make a triangle. It's going to be your typical triangle. We'll do this way here. And in this case, we're going to make a right triangle. And we want to calculate the area of that right triangle. When we calculate the area of the right triangle, we want to try and figure out what all of this shaded section is right in here. All inside, we want to be able to calculate that area. Now normally you would count squares. Well, I have one square, two squares, three squares. Looks like there's a half, that could be four. So it looks to me like this area should be about 4.5. But let's try and figure it out mathematically. The method we're going to use the first time around is what we are calling our rectangular method. And in our rectangular method, we are going to try to enclose this triangle in a rectangle. And the way that I do that is I just draw a straight line. I'm using dotted lines just to kind of show you the difference between the two. So we have a rectangle now, and our rectangle would be a 1, 2, 3 by 1, 2, 3 rectangle. So that whole thing would be a 3 by 3. And I remember yesterday we talked about area of a rectangle is length times width. So that would equal 9. If these are in centimeters, it's going to be centimeters squared. The only problem is I don't want the entire rectangle. What I do want is I want to calculate half of that rectangle, because I have a triangle in here, which is what I'm trying to figure out. This black triangle covers about half of the entire rectangle. So if I take 9 and I divide it by 2, let's do the math here. 9 divided by 2. 2 goes into 9 3 times. That is 6. Or no, 2 goes into 9 4 times. How about that? Let's do that. That's a little bit better. Haha. 2 goes into 9 4 times. 4 times 2 is 8. There we go. 9 minus 8 is 1. Add my decimal point and my 0. Bring down my 10. 2 goes into 10 5 times. So we have an area of of the actual triangle, that green section, the area equals 4.5 centimeters squared. So let's see if we're right. So we said this was 1, 2, 3 squares plus a half and a half as a whole. There's 4 plus another half. That's 4.5. So everybody see kind of how we did that? We just took our triangle and we enclosed it in a rectangle. Now sometimes, let's just do this. Sometimes we don't have these really pretty triangles. We have a kind of an obscure triangle. And when we do that, you can still use the rectangular method, the rectangle method, to figure it out. Okay, so we're going to go ahead and try and enclose this shape into a rectangle by doing this. So there's my one dotted line. Here's my other dotted line. And I have one on that side and one on this side. So now I have my entire shape enclosed in a rectangle. If I can calculate the area of the entire rectangle, that at least gets me started. So I have a 1, 2, 3 by 1, 2, 2. So I have, if this is in centimeters, let's just say each one is a square centimeter. So I have 3 centimeters times 2 centimeters equals 6 centimeters squared. So the area of the entire rectangle now, that's the red part, is 6 centimeter squares. Well, what if we just got rid of, I don't want the rectangle, I want the triangle. So if I get rid of half of my rectangle, that's the same thing as taking away 2. So now what we can do is we want to try and figure out what this other part is. So to do that, again, we're going to go and get a straight line. And this time we're going to use, I don't know, maybe we'll say it is, I think I can do it in yellow. I think it'll show up pretty well. Maybe we'll use green this time because it'll show up a little better. So now we enclose this piece of our rectangle, of our triangle, inside a rectangle. So now what I'm focused on now is just the green one. So the green one I have is a 1 by 2, so that's 1 centimeter times 2 centimeters, and that equals 2 centimeters squared. Because I don't want 2 centimeters squared, I only want to know what this black line right here, I know that black line cuts my rectangle in half, so that means that half of my rectangle is 1 centimeter. And the red half of my rectangle was 3 centimeters, because the red whole rectangle is 6. So now what I can do, and watch this, this gets a little cool, a little bit confusing, but I think you'll be okay with it. Now all I have to do is say, well, the entire rectangle is 6, so I take my 6 and I want to subtract from it my 2 pieces. My red piece, which when we calculated it, this was half of the red rectangle, which was 3, plus my green piece, which was half of the other rectangle, which the other green rectangle we said was 2, so it's 1. Now what I should be able to do is calculate an area of 3 plus 1 is 4, and 6 minus 4 is 2. So the area of the blue section should be 2 centimeters squared. Alright, now this much more confusing than the last time, but let me show you another example using the same triangle, but this time we're going to use a formula, and the formula we're actually going to go for is area equals 1/2 the base times the height. So let's kind of erase some of this stuff. I'll keep that there, and we want to keep our formula here to show everybody. So in the triangle that I have drawn over here, I said that each of these is 2 centimeters. So this length is 2 centimeters. This is my base right here of my triangle. The height of my triangle basically means how high up does my triangle go. So how tall is that point compared to where the base is? And that line can kind of go out that way, so you can kind of see where it is. So this height now is 2 centimeters. So the equation says to calculate the area, all I need to do is take 1/2 the base, which was 2, times the height. Whoops. Let me fix that. The base times height. Base is 2, my height is 2. Now, order of operations says I do my parentheses first. 2 times 2 is 4. And 1/2 of 4. Of means times. Remember, when there's no multiplication sign there, it means times. 1/2 of 4 equals 2 centimeters. And I believe that is the answer that we got for that particular triangle. So again, you got a rectangular method, which it's the first time I've seen it. I kind of like it because it's easy to see and envision. Or you can use the equation, which I really like. I think that's a lot easier to use. 1/2 the base times the height. So that is the area of a triangle. We can then move on to area of a parallelogram. Same exact idea. So let's go make a parallelogram. And the way we're going to do that, I'll do it in, I guess we could do it in black. Parallelogram is 2 pairs of parallel sides. So we have one, like, let's make it a decent size parallelogram. Here to here, and that was 1, 2, 3, 4. 1, 2, 3, 4. So there's my parallelogram, and I know it's parallelogram because each side is parallel to the other sides. So these two sides are parallel to each other, and these two sides are parallel to each other. Now, if we are doing the rectangle method, what that says, let's go get my dotted line here. Oops. There we go. What the rectangle method says, and I'll go ahead and do that in red, is I want to figure out, make a, dotted line down this side, from there to here, and I want to enclose the entire figure into a rectangle. Okay, now there's a couple of things you can look at here. If we did length times width of this entire rectangle to get the area, it's 1, 2, 3, 4, 5, 6 units by 1, 2, 2 units. So the length of the entire rectangle should be 12 square units. 12 square units. And as we look at 12 square units, we need to figure out what these shaded sections are, what that one is, and what that one is. And remember, to do that, we got to add 2 more dotted lines. When we add our 2 more dotted lines, we're going to put a dotted line here, and we're going to put a dotted line here. Because now I know I have a 2 by 2, 2 squares by 2 squares. This area of this entire rectangle is 4, and because this black line cuts that rectangle in half, that means that the area of this section is 2 units. It's also going to mean the area of this section is 2 units. And then obviously the area here, it's a 2 by 2, is 4. So the total area of this parallelogram is 4, 5, 6, 7, 8. Area equals 8 square units. Now again, not really a big fan of the rectangle method, but it gives you a pretty good picture of how to do it. What we want to do though is use a resulting formula, which is area equals base times height. So let's try and get that same parallelogram. It was 1, 2, 3, 4. 1, 2, 3, 4. We'll do this one in red, I guess. And it was down to 2, over to 4, and back up. And what I want you to focus on now is the base and the height. When we're dealing with base, I'm saying this is our base from here to here. There's our base. When I look at the height, I can calculate the height a couple of different ways. I want to go from the highest point on my parallelogram. It's either going to be this corner or this corner. We can go to either one because they're exactly the same. So now, if my base is 4 units and my height is 2 units, then according to the area equation, area equals base 4 times height 2, area equals 8 square units. That's terrible S. 8 square units. So for today, or actually for tomorrow and the next couple of days, we're going to do several problems looking at areas of parallelograms and looking at area of triangles. You can use either method, the rectangular method or the equation method. So what you got to remember is when you're doing the equation, for area it is 1/2 the base times the height. And if you're doing the equation for the formula for parallelogram, it is area equals base times height. So they're 2 slightly different equations. Alright you guys, good luck, and we will see you tomorrow. Don't forget to fill out your Google form. Thanks.